In this video, we're going to be looking at how we can use multiple timeframes in VectorBT Pro. So if you have an indicator on a 1 hour time frame and another on the 4 hour time frame, how can you combine those together and use them to generate and execute signals within VectorBT Pro? VectorBT Pro is sponsoring this series of tutorials, so if you like what you see here, go check them out at VectorBT.pro, and I'll leave a link in the description to a playlist with all of my tutorials on VectorBT Pro. So the strategy that we're going to be using to demonstrate multi-timeframes is an EMA crossover strategy. So we have the 21 EMA and the 100 EMA on the 4 hour, and we have the 50 EMA and the 200 EMA on the 1 hour. And it's going to be a long only strategy. So basically, whenever this green line gets above the red line, and whenever this blue line gets above the orange line, so when both of these conditions happen, we start sending out long entries. And then we're going to manage the position using a stop and a take profit. Very, very simple stuff, but it's going to demonstrate how we can plug in all of these different time frames together for any kind of indicator that you want. So scrolling up to the top of this notebook, which you'll be able to find in the linked GitHub in the description, I'm going to assume that you've already installed VectorBT Pro, you have that set up. If you don't have that set up, I'll leave another link in the description to where you can find a video installation guide. Normal stuff, we're just going to import VBT, and I'm going to be using data based off of this GBM OHLC data class. GBM standing for Geometric Brownian Motion, so it's just synthetic data essentially, but it will mean that we're all using exactly the same data because I've set a seed value here of 42. So when you run this and then you plot it, you should get something that looks exactly like this. So far, so good. Now let's go ahead and calculate our indicators. We want the 1 hour and the 4 hour, like I explained earlier. So if you have your own indicators, that's all well and good. But for the purpose of this video, I'm using indicators that are built in with VectorBT. And if you want to find the specific name of a indicator that's built in, you can use this list indicators function, and you can use a glob-like search, so star MA. It will find anything that ends in MA basically. So you can see all of these end in MA. It allows you to pick whether you want the inbuilt VectorBT moving average, you specifically want the TAlib one or the TAlib EMA, etc, etc. I'm using TAlib here, so I've just copied and pasted that from here. I'm using the TAlib EMA just because TAlib is really popular. Now, when you're using TAlib, I highly recommend using the parameter skip NA equals true because TAlib really doesn't like null values. And then at the end, you forward fill any values that have been skipped over. Now, in our case, our data won't actually have any nulls because it's synthetic data, but in the real world, you're occasionally going to miss a bar due to the exchange being down or something. We're passing in 2 different time periods. So if you look at the data that this cell generates, you can see that each time period has its own column. If I just enter one time period, so I just enter the 50 here, we get a simple pandas series rather than data frame. But given that we're operating on the exact same data, we might as well provide a list, make our life easier. If you want to know what kind of parameters you can provide to this TAlib, there's a function called vbt.phelp, and you can give it an indicator. So vbt.indicator, search for this one, and then .run. So any indicator .run. That will give you some more information. Of course, you can always consult the documentation, but it'll give you time period, time frame, short name, and you can see that short name has been used here. So this EMA time period. Just thought I'd show you that. You can do that for any of these indicators. So this VBT one, for example, it's helpful because they're not always called the same thing. So this is called time period, whereas here it's called window, and there's also window type here, which you can set, etc. So All good. We've got our 50 and 200 EMA on the 1 hour data. Great. This is just showing what our data looks like. So we've got simple open, high, low, close. And thankfully, VectorBT understands how to resample this data from the get-go. So I'm going to turn this 1 hour data into 4 hour data. You could, of course, if you were using an exchange, you could pull the 4 hour data directly, or the 5 hour, whatever time frame of data that you want. You could pull it directly from the exchange. But since I already have the 1 hour, and 1 hour divides cleanly into 4 hours, I might as well just resample it locally. And if your data frame just consists of open, high, low, and close, if your data instance rather consists of open, high, low, and close, VectorBT is going to understand how to resample it. And in fact, if you get data from any data source that's built in with VectorBT, so if you pull data directly from Binance, you might have a bunch of other columns, say listing the number of trades or the volume. VectorBT will understand how to resample it just by calling .resample. If you're not using a built-in VectorBT class, or you've got some weird statistic that needs aggregating in a specific way, there are ways to teach resample how to do that, but that's beyond the scope of this video. Regardless, for us, we have simple open, high, low, close, meaning that resample is going to understand how to resample everything correctly into 4 hour bars. So we have our 1 hour data, our 4 hour data. Let's do the same thing where we run TAlib on that, except we're going to run it on a 21 and a 100 EMA this time, just for a bit of variety. And you'll notice that this index is 4 hours, as we're running it on 4 hour data. It's worth noting that I've done data.run here. So if we go back up, it should actually say in the p help. So if I bring that back up again, so I do vbt.phelp, vbt.indicator, TAlib, EMA, .run. You'll notice it automatically wants to use the close value. So it'll be the same for the inbuilt VBT one as well. Obviously, we have some indicators that take the open and the close, etc. But you'll notice that when using data.run, the default will be to use the closing price. If you wanted to do the EMA on the open price, you can. It will just look slightly different. It will look something like vbt.indicator. VBT TAlib EMA.run, and then you provide all of these same values, except at the beginning you provide your data, so h4 data.open, for example. And then at the end I pull out the EMA, and this is now running on open data rather than closed data. I'm just pointing this out because it's going to be very important when we do our alignment in the next step. We need to understand which category of data this EMA belongs to. To make it simple, there are two categories. There's open data and closed data. Open data is available at the very start of a candle. So this is basically just the open value and any metric which is derived from the open value. Almost everything else will be in the closed category. For example, the close value of a bar, we don't know until the end of a bar. So that means it's in the closed category. We only know it at the close of the candle. Same for the high or the low of a candle. We only know the high and the low when the candle actually ends, because price action is unpredictable and we could have a massive spike or a dip in the last few seconds of trading. Same with the number of trades, the volume, etc. Just bear that in mind when you're resampling. So like I mentioned, our goal here is to align this data with the 1 hour data. And then typically how you will do this in almost every case is you will upsample your higher time frame data to lower time frame data. So in essence, what I'm going to do is I'm going to replace this index with an hourly index. So instead of going from midnight to 4 a.m. to 8 a.m., it's going to go midnight, 1 a.m., 2 a.m., 3 a.m. And then I'm going to map these values to the appropriate location where they should be in this new index. And the function that we're going to do that is realign. Now there are two versions, or in fact 3 versions of the realign function. We're going to be using realign opening and realign closing. You use realign opening when you're dealing with open data. So if I want to upsample the open price, I will use realign opening. For the high, the low, and the close, I will use realign closing because that data is only available at the close of a bar. So to upsample this data, we call the EMA, we do .vbt.realign closing, and you can pass a few different things in here. I usually just pass the index that I want to map everything to. So I want this index to be completely aligned with my hourly index, and that way I can easily join them together. And I'll have a data frame, so a bit like a spreadsheet, where on each hour, it will tell me what is the EMA on the hourly time frame and what is the EMA on the 4 hourly time frame. But it will tell me that at every hour rather than every 4 hours. And everything will be properly aligned so that we can generate signals based on that. There's a helpful diagram on the documentation for thinking about the differences between opening and closing data. So I'll bring that up here. Conveniently, we've got the same sort of setup with 1 hour and 4 hour data. So if you're familiar with candlesticks at all, you'll know that despite this saying here, midnight, if we had the closing value right next to it, the closing value actually represents the price at the very end of this bar. So in our case, that's going to be just before 4 a.m. And if this had its closing price written next to it, this 1 hour bar, that would be the price just after 1 a.m. And so when we're aligning these 4 hour candles with the 1 hour data, we want to align them so that they close at the same time effectively. So this candle closes at 4 a.m. This candle here also closes at 4 a.m. So when we do the realigning, this close value is going to be inserted here. And then similarly, for this 4 a.m. candle, this 4 a.m. candle closes at 8 a.m., which is exactly when the 7 a.m. candle closes in the 1 hour time frame. So this will be mapped to the 7 a.m. candle in this time frame here. Hope that's making a little bit of sense. You can mess around with these values as realign closing here and see what happens. So if I set it to realign opening, that will shift the results slightly. Have a little go with that and see if you can make it work in your brain. By default, it's actually forward filling the results. So FFILL equals false. Now it will just show the actual mapped values like I mentioned. So in this example, this is mapping to 3 a.m. This is mapping to 7 a.m. Now by default, it's going to forward fill that because it assumes that that indicator value is going to stay the same until the next value, which is normally a safe assumption. But when you're messing around and trying to figure out the logic of it in your head, it can be helpful to have that forward fill off. Now, again, we're using realigning closing here. So realign closing, because we're using closing price data. This EMA is based on the closing price. If all I wanted to do was realign the opening price for that candle, I would use realign opening. Hope that's making sense. So we also rename the columns here. That's just for ease of use. So I know exactly which one's which later on. Same for the 1 hour candles, just rename them, make sure we know what's going on. And then what we're going to do is we're going to concatenate everything together into one big data frame. So I've gone through great pains to make sure that these have the same indexes. They have the same number of rows, 8784, and all of the indexes are exactly the same. So I'm now going to use pd.concat to join everything on axis 1. And that's essentially going to stick everything together into one big data frame. I've also added the close and the opening price so that we can check that our orders are being filled at the correct time. Although that's obviously completely optional. There's a nice plotting feature that we can use. So if you just grab the data frame.vbt.plot, that will plot all of the different time series. You can turn them on and off. This is helpful for knowing when your signals are firing and double checking that your strategy logic is actually working. In terms of actually generating signals, now that we have everything aligned, and obviously you could imagine doing the exact same thing with a 6-hour or a 12-hour, or even if you had a lower time frame, say a 15-minute, then you would align everything to the 15-minute candles and you would do the exact same thing. All we have to do is apply some conditional checks here to generate our actual true and false entry signals. So it's very simple. I just take this column of the data frame and check whether each element is bigger than this column. So in particular, whether the 21 EMA is greater than the 100 EMA on the 4-hour time frame. And then I do the same thing over here. I check if the 50 EMA is greater than the 200 EMA on the 1 hour. If both of those are true at the same time, that's what this AND symbol does. Both are true at the same time, then this will be true. So if I show you what entries looks like, entries, it's just a load of true and false. I promise you there are some true signals in there. This signal will remain true for as long as this happens. So you might get a load of trues directly after each other. You're going to get a long streak of true, 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 true. That's fine because the way this is set up, so I've got long entries equal to entries. So it's only going to take long trades. And you'll notice I don't even have an exits series. I don't have any exit signals at all. I'm just allowing this stop loss and take profit to do its thing. So it will enter whenever this is true. It will go all in by default. It will exit the position whenever it hits a stop or a take profit. So a stop of 1% and a take profit of 2%. And then it will repeat the whole process again. Whenever this hits true again, it'll go all in, etc., etc. Let's double check to make sure everything's working. You'll notice I've got the price set to next open. That's just to try and avoid a bit of look ahead bias. What that does is it sets your fill price for the trade. So if we grab this pf.trades.records readable, we can see that the entry price at this time is 1110.9965. And this is the entry index. So this is the index that we're actually entering on here. And this is the price. If I change this and I comment out that line, you'll see that that changes. You'll see that it changes to 3 p.m. and the price subtly changes. If we look on the graph and we zoom right in, grab the zoom tool, we can see that from the very first candle where we have our indicator, the 21 EMA is definitely above the 100 EMA, and also the 50 EMA is above the 200 EMA. So the signal gets triggered on this first bar, and then you have to make a decision about when exactly to execute your signal. So by default, VectorBT will execute at the close price on whatever bar that you happen to set the signal to be true for. So if I zoom in again, let's get the correct time frame. So by default, this signal is going to be true. So all of those booleans are going to be true at this very first tick here on the 17th at 3 p.m. By default, VectorBT is going to assume that you can enter that position at the close of that bar. Now, depending on what asset you're trading, this is not always realistic. So it should, if we check, it should be 1110.9579. If we grab this, if we leave it to default, 1110.9579, and that's what we meant. So if I set it to next open here, instead of doing that, it should trigger on the next bar. So at 4 p.m., the price is 1110.9965. And if we go over here, 1110.9665. That's just a little extra trick to make sure your prices are properly accounted for when doing entries. Doesn't make a big difference for crypto markets, but for other asset classes, it definitely can, depending on how your signals are calculated. So that's a super simple and quick way to use multiple timeframes in any of your backtesting setups. Calculate them on whatever indicator that you want, and just upsample them using the realign function, passing in the index of the smallest time frame, whether that's 1 minute or 1 hour or 15 minutes as we have here, making sure that you select the correct realign option, whether that's opening or closing. 90% of the time it's going to be closing. Concatenate everything together in a big pandas data frame so that you can make trading decisions on every single bar of the lowest time frame that you're using. You can generate signals on each bar. And from there, it's a very normal process of generating signals by doing some comparisons between your indicators. So I hope you've learned something, and I'll see you in the next video.